All right, so in bonding, you need to know about metallic bond, ionic bond, covalent bond, and then covalent, you need to know about small covalent molecules like chlorine, nitrogen, oxygen molecules, and then giant covalent structures like diamond and graphite most of the time. Okay, and then in each of those bonding, you need to understand how to draw the structure. What are the properties of the structure? So like melting point, boiling point, um, what else? There's one more thing: melting point, boiling point. Yeah, and then also be able to explain why the melting point or boiling point is like high or low. Okay, so that's in properties, and then you need to know if they conduct electricity, why, and if they do not, then why not. Okay, electricity. Sorry, electricity. Right. So yeah, those are three things you need to know: how to draw the structure, their properties, and if they conduct electricity and if they do not. Right. Now, two things to remember before I do anything further. If there are opposite charges, so like positive charge or a negative charge, no matter what it's from, whether it's from ions or electrons, okay, whenever you have opposite charges, there are strong electrostatic forces of attraction between them. Okay, so whenever you have opposite charges, there are strong electrostatic forces of attraction between them. This phrase is very, very important. And then the other phrase that's important is whenever you have charge, now it doesn't matter if it's positive or negative or even both, whenever you have charge that is free to move around, that thing will conduct electricity. This is the second phrase that's useful. Okay, so yeah, whenever you have opposite charges, you have strong electrostatic forces between them. And whenever you have charge that is free to move around, that thing will conduct electricity. Okay, now I'm gonna start with one of the bonds. Let's do metallic. Metallic is the simplest one. Right, so in metallic structure, I would strongly recommend draw like a minimum of 12 ions. Ideally, they should all be like, equal size and all that, okay? And touching each other, okay? This is just for explanation, but do it a bit more neatly in the exam. So, now let's say I want to draw for magnesium, okay? So magnesium atom, it's in group 2, so we expect 2 electrons in its outer shell, right? In its outermost shell. Okay, we expect 2 electrons in its outermost shell, but it's in group 2. So, oh, I actually forgot to say something. So I'm going to yeah, just one thing I want to say. So why do elements get involved in bonding? That's because they do not have a full outer shell. Okay, so like group 0 elements, or you can say group 8 elements, they do not get involved in bonding because they have a full shell, they are stable. All the rest, all the rest, all the rest, they get involved in bonding because they do not have a full outer shell. So, yes, I need to erase this so that we can go through that. So, like for example, like group 1 elements, you know that they let's just label X, okay? So they only have 1 electron in its outer shell. To become full, they need to have 8. Now just think about it. Is it easier for them to gain 8, so gain the 7, or lose that 1? And obviously it will be easier for them to lose 1, because if they lose 1, underneath they have a full outer shell. And yeah, they'll be fine that way. Okay, they will be stable then. Okay, and same for group 2. So group 2 elements, so group 2, they will have 2 electrons in their outer shell. Okay, just think about it. It will be easier for them to lose those 2 instead of gain 6 to become full. So they lose those 2 electrons. And let's say group 6. Group 6 elements, they have 6 electrons in their outer shell. So just think about it. Is it easier for them to lose 6 or gain 2? It will be gain 2, because 2 is a smaller number, right? So yeah, so they will gain 2. And same for group 7. Group 7 elements have 7 electrons in their outer shell. So just think, is it easier for them to lose 7 so that they have a full shell underneath, or will it be easier for them to gain 1 so that they can just complete this current shell? Okay, I hope I wasn't mumbling. So that's the reason why um, like metals, they only have a few electrons in their outer shell, and so they tend to lose that electron. They tend to lose the outer shell electrons to become stable because they have a full shell underneath. So let me actually draw for magnesium. So magnesium is in it has atomic number 12, so Mg. So this is the first shell, second shell, and then that's 10 electrons, and this 12 shell. Okay, now think about it. It will be easier for it to lose these two, and then like there's a full shell underneath, so this one becomes an empty shell. This one, the third shell will still be there, but it will be an empty shell when it gets involved in bonding. And think about the charge. Now the atom has 12 electrons and 12 protons. Okay, and protons are positively charged. Okay, that's why as as an atom, magnesium is stable. Like it is neutral. It is not charged. But when it loses those 2 electrons, now it still have 12 protons, but now it will have 10 electrons as ions. And because there's 12 positive charge, 10 negative charge, overall there is a positive 2 charge. So that's why the magnesium atom has become a positively charged a positively charged magnesium ion with a 2 plus charge. And yeah, it is an ion now. So when it gains or loses electrons, the atom becomes an ion. So the magnesium atom lost 2 electrons to become a positively charged metal ion, magnesium ion. Okay, I hope that clarifies why is it 2 plus charge and so on. Okay, all right. Now we can go back to, no, let me just do one for non-metal as well. So like for example, chlorine is in group 7, so it has atomic number 17. So 1 2 3 4 5 6 7 8 9 10 17. I know, horrible drawing, sorry about that, but I hope you get the knowledge across. You understand the knowledge. Okay, so it has 17 electrons, and we know that it will be easier for it to gain 1 electron. So just think about it. So when it had atomic number it's atomic number 17, so that means it has 17 protons, so positive charge, and 17 electrons as an atom. Okay, so that's why it's neutral. But then as an ion, it gained 1 electron, so it gained 1 negative charge, so it has 18 electrons now. It still has 17 protons, but it has 18 electrons now. So that's why overall, with 17 positives plus 18 negatives, you end up with a -1. Okay, -1. So yeah, chlorine has a -1 charge. I forgot, do you write it like that or like that? Actually, it doesn't matter. Yeah, so chlorine has a -1 charge. Okay, and that's the reasoning why. And is there anything else do I want to say? Yeah, so the protons in chemistry, in chemistry, like the number of protons doesn't change because the number of protons identifies the element. If the number of protons change, the element changes. Like, because if it's 18, then it's gonna be argon. Okay, we're talking about argon. The atomic number, or the number of protons, you can say, they identify the element. Okay, in radioactivity, when you do physics, that's the proton number changes. You lose protons, and then the element changes to something else. And yeah, it's because the protons have been lost. It's a different element after it gains or loses protons. Okay, I hope that all made sense. Okay, now let's go back to metallic bonding. Or let me start that in another video. It's been 10 minutes on this one already. And I think there's no more, yeah, there's nothing more I want to say before I do bonding now. Right, so yeah, we'll do bonding in the other video.